Hi, my name is Chuck Odraska, and I'll be doing the SAL this week on Chapter 13 from the Tangled Web book. It's titled Content Recognition Mechanisms. What is that? It's also known as content sniffing. It's when your browser attempts to figure out what you're rendering. So, are you rendering a type file like HTML, or just trying to show plain text, or maybe a Flash program, things like that. And so, from looking at the file, it'll try to guess what needs to be rendered. And in the early days of the browsers, it would even ignore the developer's intent at points in time. Say the developer explicitly told it to use HTML. Well, for whatever reason, when it was content sniffing to try to figure out what type of file it was, it may have just said, oh, that's just a text file. It had reasons to, obviously, but from what it was looking for compared to what the developer wanted, it may have changed that. That's now forbidden in the standards of HTTP and things like that. But back then, obviously, it wasn't. Um, Also, it can be kind of a fault-tolerant thing for you. So say you forgot to put what content type it was supposed to be. Well, the browser could then try to guess. It had all these ways of maybe looking at the end of the file name, like .html, or things like that. Also, similar to angle brackets, if it was missing an angle bracket, it would try to fill that in. Well, this was trying to fill in the content type for you. So, just trying to make it load no matter what type of deal. And obviously, this causes security vulnerabilities. And the forbidden now, but only kind of, is it's forbidden to change what the developer's intent was if he specifies something that's real. But if it's missing, the browser can still try to render it for you underneath what content it thinks it is, what content it actually thinks it's sniffing. So how does a browser detect what content it should be doing, and what reasons should it have now for doing it? The three reasons are either the developer mistyped the header and the content type, so what it's supposed to be. It totally got omitted, or it got transported over something that wasn't HTTP. So, for example, FTP would be one example of that. So, other than that, those three things, it really shouldn't be content sniffing and trying to figure out what content it is. But to actually do the content sniffing, it'll look at static signatures like maybe the end of file name or the extension, so like .html or .swf, things like that, and other heuristics that the browser implemented. And it's every browser for itself, like everything else we've done this semester. You can see that there's not really a standard for how they handle this, or very well documented for that matter. If you want to read about it in the Tangled Web book, it's on page 199 what each browser does, but it's so varying and detailed that wouldn't really want to say it here. But every browser, again, just does its own little thing. And the author kind of mentions that web server scripting kind of stops this because web servers try to actively make you put a content header. They make it mandatory, and if there isn't anything there, it can try to have some kind of script that handles user requests with that and automatically put what it is itself instead of having the browser handle it. But this idea has its faults, as we'll see. So here's where we're starting into our first troubles with malformed MIME types. A MIME type is just a multi-purpose internet mail extension, so it used to be for email main purpose. It should look something like type slash subtype. So that could be text slash plain, which would be a plain text file, or image slash GIF, which is just a GIF file, an image. So things like that. You can have multiples in your content type separated out by semicolons. And then really for these, it's really only the special content type values we're worried about. Unless one big thing is don't let the user decide the MIME types. But otherwise, it's really the special content type values we're worried about. The two biggest ones are application slash octet stream and text slash plain, just because these tend to be defaults, and because of this, it'll cause problems. We'll go into these three more deeply. And then finally, unrecognized content type. This mostly has to do with Internet Explorer trying to be the content sniffing master and just sniffing out everything. Yet again, we'll get more of that in these next few slides. So what this application slash octet stream thing is, this content type, it was supposed to be a way for web servers to indicate that the return file had no meaning to the web server, and it shouldn't have any meaning to the client. This is fine, but then all files that were non-web files that didn't really have a better content type defaulted to this match. And sometimes this caused errors such as binary files, downloadable executables, or archives to display in the HTML inline. It was just a bad thing that happened, I guess. And obviously you didn't want this to happen, so that was one reason to be concerned. You didn't want your web application showing your webmail system or your binaries or your downloadable executables inline of the HTML. Text slash plain is pretty much exactly what it sounds like. It's just documents without formatting. It's also a MIME type to allow any other text-based documents to be rendered. So there's that. Really, it's just the default for those two things, like I said. But also, it happens to be a fallback for CGI scripts as well, which same as your binaries and downloadable executables and the previous one of the application slash octet stream. Same type of thing where it displays it on screen where you wouldn't want it. Mostly the two browsers that had trouble with this is Internet Explorer and Safari. So unrecognized content type is mostly an IE problem. IE tried to content validate so much, or content type and content sniff and those type of things so much that it actually caused problems. One of those problems that can be seen is in image files. Say a user supplied a JPEG image but never validated it. It could be treated as HTML. Another one you could do is serve up a valid GIF file with content type saying image slash JPEG, and this could also trigger the file being shown as its raw data into the HTML. And this is a problem, being that raw data, image data, could be some kind of attacker selected string that could cause some kind of attack on the client or the user. So to defend against some of this, three things that you can do to really help out is: one, on the content type, make sure that you are putting the correct content type and that the user can't change it, things like that. Another big one is this thing called X content type options, which IE actually, or the developers for IE actually made. You can specify no sniff, which would allow a website's owner to not use the browser's content sniffing pretty much. The book recommends this to use this highly. Unfortunately, it's only in, as far as the book goes, in IE 8 and above, and has only a limited support in other browsers. So this is good, but can't just be dependent on that this will stop things. And then finally is content disposition. Content disposition : attachment allows the developer to put files like binaries and executables on their site, and then when you click on that file, it'll ask you something similar to this box, whether you'd like to open it with something, save the file, or don't do anything with it. You can cancel out. And so this allows you to put those types of files on there. One thing to notice about this though is the user still has the option to open this, so that might not be an actual defense anyway if the users aren't wary of things like Flash and things like that, that they should instead maybe save, or it just kind of gives them a wall in between instantly opening up a Flash instead of clicking on it and it's right there. It'll at least say something like that's there without them getting a hit with it, and then they can just cancel out and they'll be fine. And again, there's lots of little things for these, that little bugs pop up when these were implemented, and these themselves can't all be relied upon. We're getting to character set handling, which for text-based documents, they can content sniff for the character set. The usual is UTF-8 or UTF-16. Some unusual and dangerous character sets include non-canonical representations of standard 7-bit ASCII codes, variable length encodings, and encodings incompatible with 8-bit ASCII. I have a few slides here that'll give you a better understanding of the first two, and the third one is just things like UTF-16 and UTF-32, just completely incompatible, so there's no real way to show that. It'll just cause problems. So first, for the non-canonical representations, say you had some HTML, if you ignore the bullets on the side. This is pretty much just something, and you can see in the middle this plus ADW minus, and this plus AD4 minus. You might be able to pick out what it is, but it's just a JavaScript alert encoded as 7-bit ASCII code. And so it actually looked like this. Now obviously this would cause problems because then you could embed script through various methods. And then the variable length encoding. This one just has to do with this 0xe0 right here, which allows this to go across multiple lines. And as a result, the HTML tag is not terminated as expected, allowing an on-air handler to be put in there, which will, as it says, this alert will execute, so being able to put more JavaScript in there. So IE has another little fun thing it does with character sets. It gives precedence to byte order marks, which are just bytes of data at the beginning of text files to tell it what type of encoding you use. And because these take precedence, sometimes these can cause errors. So things like we talked about the UTF-7, being able to do that or possibly just doing incompatible things like UTF-32 would also be a problem. That's just another thing that IE you have to be aware of. They do strange things sometimes. Then here are some last few minor things to hit on for character sets. Character set inheritance and override. So on your frames, the top level frame can set character set, and the bottom level frames have to obey it. Um, this has since gone away for most browsers, but it is still available on Opera. Another one is override, which is you're able to manually set what encoding scheme you use in your browser, and this can cause all your selected frames and everything within your page to be that encoding, which could also cause trouble. Something cool like maybe you could say, look what this does in this encoding, and you tell them how to do it. You could actually probably attack someone without them knowing it, just by having them set their encoding for themselves to something like UTF-7. Next one, markup control char set on sub-resources. So things like style sheets and scripts. Problem in this is encoding specified by the markup overrides HTTP data. This really only occurs in Internet Explorer 6 though, so even though that's kind of a still popular browser because of businesses that are still have that around, this is a less worrisome than it was. And then finally, detection for non-HTTP files. If you're loading in a file not using an HTTP protocol, such as file protocol, it's an unusual means of loading, so it doesn't necessarily have to fit the character set of the page. And this can cause problems, as mentioned, for the previous encoding schemes. That is pretty much it. Those are my sources. Hope you enjoyed this week's salad. Thanks.